Hey guys, this is Excellent the Maths Doctor, and today we are gonna be looking at solve for x, which is a very simple topic. And guys, so let's solve for x, and then the equation that we are going to be solving for x, using k 3x to the exponent of 3 over 4 then equals to 81. So in this equation, if we want to solve for x, let me just show you how the first step will go, right? Firstly, we're going to let me rewrite the equation. Get 3x to the exponent of 3 over 4 and then equals to 81. So remember, when you're solving for x, the main idea is that at the end of the day, x is essentially on one side of the equal sign alone. Ne? So you must leave x on one side of the equal sign without any other numbers. So the first thing that we're going to be doing, re tlo remove the coefficient ya 3 in front of x here. So I'm going to divide by 3 on this side, divide by 3 on this side. You understand? Ge ke divide by 3 on both sides. The 3 here on top in the numerator and the 3 in the denominator here, they tlo cancel and they're going to cancel each other so that we can be left with x to the exponent of 3 over 4. So at the end of the day, we want to have x only on one side. Okay? So I'm just going to write x to the exponent of 3 over 4 on this side, then equals to, then 81. If you take 81 and divide it by 3, you're going to get 27 as the answer. So first step, remove the coefficient of 3 in front of the x exponent 3 over 4. Then you're going to be left with x exponent 3 over 4 on the left, then equals to 81. When you divide it by 3, it's over 27. Okay? So I'm dividing by 3 on both sides, because what you do on the left hand side of the equation, you must also make sure that you do it on the right. Okay, then the next step from here, this is what we're going to do. I'm gonna write x to the exponent of 3 over 4 in brackets, ne? And then I close the brackets like this. And then outside of the brackets, I'm gonna write an exponent longer. It is the reciprocal of 3 over 4. When I say the reciprocal of 3 over 4, in simple terms, it just means you're gonna switch the position of 3 and 4. You switch the numerator and the denominator, so you flip the fraction, you understand? So if on a 3 over 4, you switch them, it becomes 4 over 3. You switch the numerator and the denominator. So this is what we're gonna write outside of the brackets here. We write the reciprocal of 3 over 4, which is 4 over 3. So we just switch the numerator and the denominator like that. And then next we say equal to, then on this side we have 27, right? So I just write 27 like that, and then Leona, I have to raise it to the exponent of 4 over 3, just like I did on the left hand side, because I explained what you do on the left hand side of the equal sign, do it on the right hand side as well. And then from here, okay, it's gonna be, okay, we have 4 in the numerator here, 4 in the denominator, so they're gonna cancel each other like this. You see, even the 3 and the 3 here, so 3 on top, 3 in the numerator, 3 in the denominator, they are cancelana. Even 4 in the numerator, 4 in the denominator, they cancel each other as well. Then what we are left with is what is x. So the main idea of raising the fraction, I mean the what do we call it, the term to the reciprocal of the fraction, is so that we can be left with x. So we are just trying to remove the 3 over 4, so that's why we raised it to the reciprocal of 4 over 3, so that we can just have x. And then equals to, then 27, we are going to write it in the form of, we're going to convert it to a prime base. Ne? When you convert it to a prime base, it means, or you're going to write it with a base of a prime number. For example, if I write it as 3 cubed, right? 3 cubed, the base is 3, so the base is a prime number. So that's what it means. That's how you write it. You write it with a base of a prime number. 3 is a prime number because it only has two factors, which are 1 and the 3 itself. Then it's 3 cubed, which is 27, then to the exponent of 4 over 3 like this, right? Okay, then here you're just simply gonna do it like this. Okay, right, so 3 to the exponent of 3 here. The exponent of 3 can be written as 3 over 1. Ne? I just want to write it like this so that when I, go through certain steps, no one gets confused. So 3 can be written as 3 over 1 because every number has an invisible denominator of 1, just like every number or every variable has an invisible exponent, yeah, 1. So I'm going to write 3 over 1 like this. Then 3 on top here in the numerator will be cancelled with the 3 in the denominator here. Then we are left with what? With 4 over 1. And 4 over 1, mind you, can just be written as 4. You don't have to write the denominator of 1. Even the 3 here, we didn't write the denominator. I just added it just so that when we cancel, everyone can understand where the cancellation comes from. Because remember, when you cancel if the other one is in the numerator, the other one is in the denominator, and it's multiplication. So yeah. Then on the left hand side we still have x. So okay, x is equal to 3 to the exponent of 4. Therefore, it means what x is equal to 3 exponent 4 is equal to 81. Then this is the answer. You just solve for x like this. This is a very easy, equation, you see. Okay, let's take another example. Let's take another example. Another simple example. I'm going to be explaining it throughout all the steps. Okay, now we can just look at, okay, we have 2, let me write it down, 2 to the exponent of x over 3 then equals to 1 over 128, right? So if you have an expression like this, what are you gonna do? Okay, if you can look for today, in terms of solve for x, I'm using exponential equations for our solve for x. So I need you guys to understand it, a little bit more better. Okay, let's do it like this. So we're gonna have 2 to the exponent of x over 3, then we say equals to 1 over 128. I want us to write 128 with a prime base, ne? I want us to write 128 with a prime base. When we write it with a prime base, it will be 1 over, okay, it's gonna be 2 exponent 7. Right, so 128, when you write with a prime base, is gonna be 2 exponent 7, right? You can even do it on your calculator using the shift fact method, you understand? So 128, you can write it as 2 to the exponent of 7 like this. That's the first step. Then next we're gonna say 2 to the exponent of x over 3 then equals to, then we have 2 to the exponent of 7 in the denominator, ne? Let's try to remove it from being a denominator like this so that we can take it into the numerator, ne? So when we take it into the numerator, there are some few changes that are going to take place because we want it to be like this one. We don't want it to be in the form of a fraction like this where we have 2 exponent 7 in the denominator. No, we need to take it to the numerator up, you understand? We remove it from being the denominator, take it to the numerator. That way it will be easier to solve. So when we take it to the numerator, the change that is going to take place is that the exponent, which is 7, the sign of the exponent is going to change. So if you have 7 like this and you take it to the numerator, the exponent will now become a negative 7. So the sign of the exponent 7 will change from positive to negative. If it was positive, it's gonna be negative. If it was negative, it's gonna be positive. So it changes because you are taking it from a denominator like this to the numerator. You understand? Then someone can ask, well, what happened to the 1? The 1, okay, the 1 is still there. I can just write it here, ne? But the reason why I don't really have to write the 1 is because if I say 2 exponent negative 7 times 1, it will just be 2 exponent negative 7. The 1 will not make a difference. So that's why I don't have to write it, you understand? So the 1 is there, but if I say 1 times 2 exponent negative 7, it will just be 2 exponent negative 7. The 1 won't make any difference. Okay, then from here, this is how you're going to do it. Now the base is the same. You see it. We have a base of 2 and a base of 2. That's why it was important for 2 exponent 7 to go to the numerator so that we can have a common base on both sides of the equal sign. So we have base 2 here and base 2 here. So if the bases are the same like this, all you have to do is just to take the exponents, exponent x minus 3 and exponent negative 7 on the right hand side. You equate them. You understand? So exponent x over 3 on the left hand side, then we're equal to, on the right hand side you just write negative 7. So you equate the exponents as long as the bases are the same on both sides of the equal sign. You understand? Okay. Then next, we're going to times both sides by 3, ne? The reason for that is so that we can remove the exponent, the denominator at 3 under x there. So we're going to say x over 3 times 3 like this, then equals to, it means that even negative 7 we're going to have to times it by 3 because we do the same thing on both sides of the equal sign. Then it means that 3 here will cancel 3 here, right? Then we're left with what? With x. Then I can write x here. then equals to negative 7 times 3. Even if you put on your calculator, it will give you negative 21. So x is equal to what? To negative 21. Then yeah, basically this is the answer. So this is all. I hope you find these activities very helpful for you guys, right? Then if you are interested in my lessons, just make sure that you contact the number 081 703 1197 for you to enroll in my classes. You understand, guys? Okay. Thank you so much for your time. I really appreciate it. And make sure to subscribe and like the video if you found it helpful. Thank you so much. Bye.